My name is Paul Greenlaw. I'm a 5G solutions architect with Comdex. I will be presenting today an overview of the 5G service-based architecture and will provide an overview of the network functions. The topics that I will be covering will be the 4G architecture overview, the 5G service-based architecture, and then an overview of each of the 5G network functions. Let's look at the 4G architecture. 4G introduced the concept of an IP flat architecture. Prior to 4G, mobile networks used a combination of technology implementations. For example, 3G used an overlay model with TDM for voice and IP for data. 4G is the first mobile technology that normalized the implementation of IP, and it uses it as a common transport protocol for all traffic. This makes the network more scalable and simplifies its deployment, management, and maintenance. It allows for the implementation of an optimized network design that can make better use of network resources while still being able to provide differentiated services treatment to the traffic. This IP flat network model has been carried over to 5G technology as well. 4G is based on a point-to-point architecture with very well-defined 3GPP interfaces. The diagram shows all the interfaces between the entities. Let's look at the different network functions for 4G. We have the eNodeB, the MME, the S gateway, the P gateway, the HSS, and the PCRF. Starting with the eNodeB, this is the entity that handles all the radio access functions. They include radio admission control, radio bearer control, connection mobility control, dynamic allocation of resources to the UE in the uplink and downlink direction, forwarding of the user plane data towards the S gateway. The Mobility Management Entity, or MME, handles control access to the network. It handles authentication, mobility management, tracking area list management, the bearer management, and the selection of the S gateway and P gateways. The S gateway serves all data traffic from the EU-TRAN. The EU-TRAN is the RAN aspect in 4G. It handles packet routing and forwarding, is the local mobility anchor for inter-eNodeB handovers, and it also handles lawful interception. The PDN gateway, or P gateway, is the IP anchor point for all bearers. It is the entity that allocates the IP address to the UE. It provides per user based packet filtering, and it provides connectivity to the packet data network. The PCRF contains all knowledge of the policies that will determine how to enforce charging and QoS aspects in the 4G network. For example, with PCRF, the network is able to block or allow IP flows for access to services. It can also enforce bit rates on IP flows. It is important to note that the PCRF contains the policies, but the execution of these policies is done by the PDN gateway. Then we have the HSS, the Home Subscriber Server. It is the entity that stores the subscriber profiles and service capabilities. It has information such as the subscriber identity, also known as IMSI, and it has all associated user keys for authentication. It also knows who the serving MME is for the user. It contains information such as subscriber allowed, APN, roaming capabilities, and service capabilities. Let's take a look at the 5G service-based architecture. 5G introduces a services-based architecture where the control plane is based on a model where services and capabilities are exposed by network functions via service-based interfaces. Once a 5G network function registers services with the network repository function, these can be exposed to the environment, allowing authorized consumers to utilize it. The network functions that expose their services are called producers, and those that utilize their services are called consumers. Most network functions typically perform both of these roles. The 5G architecture can be depicted in an SBA or service-based architecture form as shown in the diagram, or in a point-to-point reference form similar to 4G. The service-based architecture offers the flexibility of having multiple entities serve the same function with different capabilities and services. The architecture allows for a very organized model to introduce and remove network functions from the environment without disruption to its operation. It also provides a secure means of commissioning a new element, given that it has to go through a registration process with the NRF, which will ultimately be the coordinator of the service in the environment. Unlike 4G, where the operator needs to handle the provisioning of all the point-to-point reference points, the service-based architecture in 5G makes the process automatic. In other words, the point-to-point network architecture is developed based on the result of the service-based architecture procedures. The NRF learns about the services from the producers via the registration procedure, and consumers discover available services via the discovery procedure. The language used for these procedures is based on HTTP REST commands. Let's now look at an example of a network function registering its services with the NRF and another network function requesting its services. Let's say a PCF is being introduced into the network. It goes through a service registration process to register its service capabilities. It does so by using the HTTP put message to advertise its information to the NRF, and this one in turn sends back an acknowledgement. Now this PCF, which is a producer of services, is able to provide its services to authorized consumers. Now let's say an AMF needs the services of a PCF. It uses the service discovery process to query from the NRF available PCF services. It uses the HTTP GET message to query for a set of specific services to the NRF. It then gets back a response with the PCF information based on the requested capabilities. The AMF is now ready to consume the services of the PCF and sends a service request to the PCF using the HTTP POST message. In this case, is querying for QoS policy related data, and it gets back an HTTP response with the requested policy information. Let's look at the UPF, the user plane function. It is responsible for packet routing and forwarding. It can provide packet inspection and user plane policy rule enforcement. It is the entity in the network that deals with lawful intercept. It can support traffic usage reporting, and it can be the branching point to support multi-home PDU sessions. It handles quality of service for the user plane. It provides packet filtering, gating, and uplink and downlink rate enforcement. Depending on the networking scenario, it is possible to daisy chain several UPFs to get traffic from a UE to a particular data network. The functionality of the UPF is directly controlled from the SMF. The AMF is the Access and Mobility Management function. It is responsible for the termination of RAN control interface N2. It also terminates the NAS signaling on N1 interface, and it provides NAS ciphering and integrity protection. It is responsible for access, authentication, and authorization. It is the security anchor function and security context management for access security key handling. It handles registration, connection, reachability, and mobility management. It does not control the session management, but it is the transport between the UE and the session management function. It also provides SMS transport between the UE and the SMSF. It is the entity that actually controls lawful interception. An AMF optionally supports the non-3GPP interworking function via the N2 interface and terminates NAS signaling. The SMF is the session management function. It is responsible for the establishment, modification, and release of sessions. It is also responsible for the allocation of IP addressing and the selection of the UPF. It establishes connectivity with the PCF for policy control functions. It works together with the UPF for policy enforcement and quality of service. It supports charging interfaces for the collection of charging data. It participates in the control aspect for lawful intercept. It is responsible for the termination of session management parts of NAS messages, and is responsible for the control of roaming functionality. The network slice selection function is used to assign network slice instances to the UEs. It is basically outsourcing some policy decisions from the AMF and also allows to centralize some decisions that would otherwise be distributed. It determines the allowed slices a UE can use. It determines the AMF to be used to serve the UE, and it selects the set of network slice instances that will be serving the UE. The UDM is the Unified Data Management Function. It is responsible for executing several functions requested by the AMF. These include authentication, credential processing, user identification handling, access authorization, registration and mobility management, and SMS management. The AUSF is the authentication server function. It is the entity that does the authentication for a specific device, and it utilizes the authentication credentials created by the UDM. The UDR is the Unified Data Repository. It is the backend to the UDM, and it stores all the subscriber data. The PCF is the policy control function. It supports a unified policy framework that governs network behavior. It contains policies for quality of service, charging, network slicing, roaming, and mobility. Policy control can be related to data sessions or non-data sessions. Policy control not related to data sessions refer to how the operator can control the way a specific user can access the network. The UDSF is the Unstructured Data Storage Function. It's a functionality in the 5G core network that allows elements to store their session data and become session stateless. An example of such data can be the UE context. The NRF is the Network Repository Function. It is the network function that keeps track of all available services from the network functions. The NRF learns about the services from producers via service registration. Consumers discover available services via service discovery. Consumers can then perform service requests directly to the target producer. All network functions interact with the NRF. The N3 IWF, or non-3GPP interworking function, is the network function that handles interworking between non-3GPP access and the UPF. It supports IPsec tunnel establishment with the UE and relays over N2 the information needed to authenticate the UE and authorize it access to the 5G core network. It also relays uplink and downlink control plane NAS signaling between the UE and the AMF. The SEPP is the Security Edge Protection Proxy. Its main responsibility is to protect the interactions between P elements. As such, it is used widely in roaming networks. It provides functionality such as message filtering and policing on inter-P element control plane interfaces. It also provides security functions such as topology hiding. The NEF is the network exposure function. It provides a means to securely expose the services and capabilities provided by 3GPP network functions. The NEF provides monitoring capability, provisioning capability, and policy and charging capabilities.